Today we will talk about Python user-defined functions. In order to create Python user-defined functions in Monet, we have to meet two conditions. First, we have to install this package because Monet will use this package to communicate with Python. And second, in our database, we have to enable usage of Python. I will not now explain how to do that because I already gave you an explanation inside of this blog post. So I will open this blog post, I will go to it, and here we can see how to install this MonetDB Python 3 package and how to enable Python. And now I will talk about NumPy and pandas because in my examples I will use these two Python packages. So I will go now to terminal, and first I will check whether we have NumPy installed. So I will run this command, and we can see that we do not have NumPy, and we also don't have pandas. Now, from recently, Ubuntu doesn't allow us to use pip in the global environment because Ubuntu wants to keep this global environment under his control because Ubuntu is internally using Python. So we have to install NumPy and pandas from official repository. So first I will check, do we have NumPy and pandas in the official Ubuntu repository? So I will run this command sudo apt search, and I will provide my password. And here we can see that we do have NumPy in the official repository, and it is the same for pandas. So I will now search for pandas, and here we can see pandas package, and I will now install them. Now pandas is depending on NumPy, so first we will install NumPy. So I will run command sudo apt install NumPy. I will run this, and now NumPy is installed, and I will also now install pandas. Now we can check again whether they are installed, and we can see first the version of NumPy, and we can also see a version of pandas. So we have them installed. I will now clean my screen. Next, I will create one sample table, and I will paste this SQL statement. So I will create a table, PyTab, with 3 columns, letter, sign, and number. I will create it. Then I will insert some data inside of this table, like this. And then we can read from our table to see how our table looks like. So we have a simple table with 3 columns. I will now clean my screen. I will now show you one simple function that is created by using Python. And this is that function. Here we need to declare that we will use Python as a language, and this is body of our function. So this function will accept 2 arguments, val1 and val2. They are of char data type, and then we will return those arguments concatenated. So I will run this, and then we can test our function by using select statement. This select statement will use this function to create this 3rd column. So I will run this, and we can notice the result. So we just have concatenated a sign from this 1st column and this 2nd column to get this 3rd column, except in this 4th row. In 4th row we have a problem. We have a null inside of sign column, so the result will also be null. But we want to avoid this problem, so I will show you an improved version of this function. I will paste it here. And in this improved version, we will first test, do we have a null? And if we have a null, we will replace that null with an empty string. I will create this function, and then again I will test my function with select query. I will run it, and this time instead of null we will actually have an empty string. So letter B concatenated with empty string will give us a letter B, so the result will not be a null like in previous case. Now, from this example, we can better see what is the true nature of arguments inside of this Python function. I will jump to this web page, and I will tell you that arguments are actually NumPy arrays. Just like in this example here, we will create one NumPy array, and this will be true for this first column, for letter column. But for sign column, it will not be totally true, because here we have a null. And in this case, we will actually use something that is called masked array. So here is an example of a masked array. Masked array is actually normal NumPy array that is provided with a mask. And this mask will be true for each value that is invalid or unacceptable. In this case, this value is unacceptable. So if we create this masked array, this unacceptable value will be ignored. For example, if we calculate what is the sum of this masked array, this value here will be ignored. So the result will be 1 plus 3 plus 4, that will be 8. Previously, we have this example in which we first tested whether our NumPy array has a null value. So we tested whether this array is actually masked array. And if it is, we use this command to replace null value with an empty string. And thanks to that, instead of having null here, we actually have this empty string, so the result was letter B. I can also tell you that data type of arguments inside of Python will be inferred directly from the SQL data types. For example, if something is Boolean in SQL, it will be a NumPy integer with 8 bytes in Python. And similar to that, if we have big integer, that will be, for example, NumPy integer with 64 bytes in Python. I will now clear my screen. We will now investigate what is a returned value from Python function. I will give you this example here, and this is a simple example where our function will return hard-coded NumPy array. So we can see that we don't have to calculate anything. Although we have arguments here, we can return a constant value. So I will run this, and then we can test our function. So I will use it inside of select query, and I will get a correct result. So this array here is used here as the result. We can see this value ZZ at the end, so this will work. We can also return a scalar. So I will give you such example. I will return number 3 here. We will test this function, and we will see something interesting, because this number 3 will be used just in the first row. So this is just like an array with one element. Next, we can test what will happen if we return a tuple. So I will return this tuple, and this will be successful. But when we now try to read from our function, we will get this. We will get a message, and this message will tell us what can be a returned value from Python function. It can be a list, a dictionary, NumPy array, masked array, or pandas data frame. Let's see, is this true? First, I will try to return a normal Python list. So I will have a function like this one. So we will just return a list. And I will then try this function. And we will see that this is successful. We can use a list as return value. We can also use dictionary as return value. So I will give you this other example. So here is our dictionary. It has one element with the name result, and then here I have used a list. So I will run this, and then we will test this example 2, and we will see now that we will get only A and B inside of this first row and second row. And this is something that we could expect. And at the end, we will try pandas data frame. So I will try this example here. Now, what is interesting here is that we do not have to import NumPy, but we need to import pandas. So pandas will not be imported by default. So we have to use this line here. So I will create this function, and then again I will use this function inside of select query, and we will get this as a result, so this data frame will be the result of our function. I will now clean my screen. When working with Python, we have to know its specifics. If we do not know, then we can have some problems. For example, I will show you one really simple, naive function. This function will accept an argument and it will return an argument. But when I try this function inside of my select query, I will get an error. And this error is that this identifier here is not defined. So why is this happening? Well, in SQL we can use upper and lower letters because SQL is not case sensitive, but Python is. So inside of Monet, each argument will be transformed to lower letters. So we cannot use upper letter here inside the Python function, we have to use lower letter. Let me show you this other example with lower letter. So this is the same function, just this letter here is changed. So I will create this function and then I will run this function and we will see that now everything is working correctly. One more thing, inside of Python we have to be careful about indentation. If our indentation is not consistent, like in this example, we can see here that the indentation is much bigger than here, we will have a problem. So I will create this function, but when I try to run it, I will get an error, and this error is because indentation. Now, when we talk about procedural SQL, we saw that our procedural SQL functions can return tables. Is it possible to create a table with Python? Well, that is possible. And I will give you an example of such function. So here is one function. This function will first create one empty dictionary, and then it will place two elements inside of this dictionary. Names of these elements will be actually names of columns, and these lists here will be values inside of our columns. So I will create this function, and then we can read from this function, and we will see that we will get a table. And this is a table with names just like in this dictionary, and the values are just like inside of these lists. I also want to tell you that if our function is returning true or false, so I will give you an example of such function. So this function will return either 0 or 1. This operator here is modulo operator, so 0 or 1 can be considered as false or true. Then we can use such function inside of the where clause. For example, I will run this statement here, and here I will tell Monet to filter only rows where this function is returning true. So I will run this, and we can see that only rows where we have 2 will be returned. Other rows with even numbers will be eliminated by filter. I will now clear my screen. We know that it is possible to group values from our table. I will give you this statement here, which will group our values by letter column, and it will sum values from the number column. We can do the same thing with built-in function, or we can use a user-defined Python function. So we can create something like this. So it is the same statement, just instead of sum function, we are using custom function. I will now show you how to create this function. I will jump here to this web page, and first we will take a look at how arguments will be presented inside of this function. Again, we will have this number column presented as a NumPy array. But we also need to know which row belongs to which group. In this case, we are grouping by letter column, so we have two groups. We have group A and group B, and we can see on this image here how to represent these groups. So we can say that A group is 0, B group is 1, so we can again represent our groups with NumPy array. And even if we group by several columns, for example, we can group by letter column and sign column, then we would have 3 groups. We would have A plus, A minus, and B null. Again, we can represent our groups with NumPy array. And this NumPy array will always have the same name. It will be called aggregation group. So this will be the name of this array. So we have two NumPy arrays as input. We have our argument, and we have also this aggregation group array. And let's now see our function. I will paste my function here inside of terminal. So this is our function. I will create it, and then I will jump here to this web page, and I will tell you how this function will actually work. So we can go here below. This is our function, and here are some interim results and some pseudocode. So we will start with inputs. Inputs will be our number column and our aggregation group. And they will have these names because our argument is named val. So our number column will actually be called val, and aggregation group is always aggregation group. We will apply this code here. We will take only unique values from aggregation group. So this will be the result. So if we remove duplicates from this array, we will get this. Next, we will create an array that only has zeros and has the same size as this unique array. Because unique array has only two elements, this other array will also have only two elements, and both of them will be zeros. So this is initial result of our function. Now we have to replace these zeros with appropriate values. And for that, we will use this loop here. This loop here will loop through I counter in range from 0 to 2. That means that I will go from 0 to 1. This is pseudocode. So we will execute one iteration for each group. And then for this first group, that is for 0. 0 is group where we have letter A. We will first check in our aggregation group. So this is our aggregation group. On what places do we have 0? So this here will be true, 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 and then false. And when we apply this as a mask on our number column, we will only then sum first three numbers, because we have true only for these three numbers. So sum of 1 plus 2 plus 3 is equal to 6. And similar to that, in a next iteration, we will check where we have letter B. So we have letter B only on the 4th position. So we will only take this number 4. So the result will be 4. And the final result will be 6, 4. I will now go back to terminal, and I will test that inside of Monet. So I will run this statement that will use this PySum function, and we will get the result 6 and 4. But there is one problem here. What if we use this function without grouping, without group by? So we want to calculate a total of number column. If I run this, I will get an error. And this error is because if we do not have group by, in that case, this array aggregation group doesn't exist. So we have to solve this problem, and we will solve it by making a change inside of our function. So we will create a function that looks like this. Here I'm using try to catch that error. So if we do not have aggregation group, then this will not be executed. Instead of that, we will execute this. And this will calculate the total of our column. So here we are not using aggregation group, so we don't have to worry. So this will not cause an error. So I will create this function, and then we can again try to use this function on a statement that is not applying group by. So we don't have group by here again, and this time this will work. We will get 10, which is 6 plus 4, because we will apply this calculation here. I will now clean my screen. At the end, we will take a look at some system tables. I will first read from this system table function types. I will run this, and here we can see that if our function is returning a table, then its type ID is 5. If it is aggregation function, that means function that can be used inside of group by statement, then its type ID will be 3. And scalar functions that can be used to create a new column have type ID 1. Next, we will take a look at system table function languages. inside of this table, we can see different programming languages that can be used in Monet. And we can see here that Python has language ID 6. And then we can search for one specific function that we have created during this video. And I will search for function ret inside of this system table, inside of system table functions. I will run this, and here is the data about our function, but I'm interested in this column language and this column type. So here we can see that this is the function that was created with Python, because Python has language ID 6, and this function is of type 1. That means that this function is actually a scalar function. And by using these two columns, we can filter this functions table to find functions that are made by Python and that are of specific type.